Right, so I have several different titles for this talk. Another alternative talk for this, an alternative title for this talk would be Programmer Happiness. I've been a programmer for 25 years, and during my career, things have gotten gradually worse. They've gotten more complex and slower. You know, back 20 years ago, it was basically just you, the editor, and the compiler, and not lots of frameworks. And things have grown over the time. And I used to be able to really quickly get into this zone of programming, where I just forget about everything around me, and I'm just programming. And has anyone had that experience? You know? You just forget about everything else. And I find it increasingly harder to get into the zone. I think this has to do with a lot of things. Machines are getting faster, everybody knows that. But at the same time, libraries and frameworks and tools, there's just getting more and more of them. Is anyone here doing JavaScript development? Right, so you know what I'm talking about, right? You have to deal with Babel and Webpack, and you have to spin up Docker containers and all of this stuff. And it's just really, really hard to get into the zone nowadays. And I think it's something that people have almost forgotten about. I think young programmers, people who are joining the programming profession today, they might not even know what it's like. So I've been interested in programmer happiness or developer experience for a long time, but I'm becoming even more interested in it in the past years because I think the technology is taking a wrong turn. So I want to talk today about how can we get back into the zone, how can we make acceptance tests fast, how can we get fast feedback, and so on. So I want to start off with a little bit of psychology, a couple of references to some psychology books that I've read. It would be a lie to say that I've read them, from page 1 till the end, but I've read sort of like the first half of it, and then I've flicked back and forth, and other people have pointed me to these books. But there are some interesting things in this book by a lady called Kendra Cherry, 3 components of flow, and we're talking about psychological flow here. One is immediate feedback. So in order to get into this state of flow, you have to get immediate feedback on whatever you're doing. Right? If feedback doesn't happen, you cannot enter the state of flow. You also need to have the feeling that you can succeed in what you're doing. If you're not sure whether you're heading in the right direction, you have this nagging worry all the time that prevents you from entering into a state of flow. And the third thing she mentions is that you have to feel so engrossed in the experience that everything else just becomes negligible. You forget that you're hungry, you forget that you need to make this phone call, hopefully you don't forget that you need to go to the toilet, but you just forget about everything else. There's another book as well by a gentleman called Mihai Csikszentmihalyi from Czech Republic, I think. Similar stuff. His book is called Flow, and it's about the components that he talks about that are important is intense concentration. If you're super, super concentrated, you get into the state of flow. But if you get interrupted all the time by various things, either by other tools or technologies, or maybe people, if you're sitting in an open environment, for example, it's difficult to get into the state of flow. And when you're in a state of flow, you have this merging of action and awareness. You can't really tell them apart. Talks about the same thing as what was her name? Kendra Cherry. You lose sort of the reflective self-consciousness. And you have this sense of personal agency that you control the situation. Sports people If you do some kind of sport, you're probably familiar with this feeling that you feel that you completely control of the when you're skiing, for example. That I like to ski. It's just I stop thinking. Everything is just flowing naturally. Distortion of temporal experience. You look at your watch and you realize that 3 hours just flew by, right? This doesn't happen if you are not in a state of flow. You're looking at your watch and it's 5 minutes and you're looking at your watch and you just can't wait for the day to be over. And finally, he talks about autotelling experience. That means that whatever you're doing is an intrinsically rewarding experience. Just doing what you're doing gives you joy. And this is what programming should be like, I think. But I think for a lot of people, it isn't like this, because there are all sorts of things that prevent us from entering this state of flow. And one of those things is really, really slow acceptance tests. Now, a couple of decades ago, this is the last book I'm going to refer to, Jakob Nielsen, who kind of founded the usability engineering movement, did some research into people's ability or how different time delays, how they affect people's perceptive abilities. So he discovered that there's 3 time limits that you need to keep in mind when you design user interfaces in order for those user interfaces to be usable by people. And the first time limit that Jakob Nielsen talks about is 1/10 of a second. If you have a user interface and you do something, you click a button, and you get some sort of feedback within 1/10 of a second, the user will feel like this is a system that is operating or responding instantaneously. The user cannot distinguish between instantaneous and 1/10 of a second. It just feels like you click a button, you see the thing immediately. And if you can respond that quickly, you don't need any sort of visual feedback like spinners or progress bars and stuff like that. 1 second is the next limit that Jakob Nielsen talks about. And that is the limit for the user's thought to remain uninterrupted. If it takes more than a second, your mind starts wandering a bit, and that's when user interface designers decide to put up some sort of visual cues like little spinners and stuff, just telling the user that don't go away, that you're going to get something back pretty soon. So you don't need those kind of visual feedbacks, but the user by 1 second, the user has lost the sense of operating directly on the data, right? And the third time limit that Jakob Nielsen talks about is 10 seconds. And this is the limit for keeping the user's attention focused on the dialogue. If you're working with a user interface where feedback takes longer than 10 seconds, you will lose them. They will go and do something else. They will go and check their email. They'll go and alt-tab into some other social media stuff just to fill that gap with something meaningful. So feedback is incredibly important. Now, I'm talking about user interface design here, but what about programmers? What is this like when you're sitting in your text editor or in your IDE, you do something? How long do you have to wait for feedback? You write some line of, maybe you write a new method, maybe you refactor some code. How long do you have to wait until you know whether or not you completely screwed everything up? Well, if you have to wait 10 seconds for that, that's going to take a massive hit to your ability to concentrate on what you're doing, and consequently, it's going to take a massive hit for your ability to be productive in a team. So fast feedback is incredibly important. And obviously, there's some people have to wait more than 10 seconds, right? Some people have to wait 2 weeks at the end of the sprint before they know whether or not their code is working or not. Now, that's a different class of problem. That's an organizational problem, right? So you can't. I'm not going to tell you how to fix that today, but hopefully I can give you some hints about how you can make the feedback cycle for tests really fast. So we don't want people to go and fence in a corridor while they're compiling the code or while they're running the tests. So what has the industry come up with to address this problem of slow feedback? Well, there's one thing that I'm sure everybody's heard about, and that's the test pyramid. What does the test pyramid say? Test pyramid says that out of all of the tests that you have for your system, you should have a certain proportion of unit tests. Most of your tests should be unit tests. And then service tests, whatever that means, you can have not quite as many of those, and you should have relatively few user interface tests. Because UI tests, as we all know, are brittle, they're expensive to write, and they're time-consuming to run. Right? Well, this is the conventional wisdom. But I think, I'm not sure I agree with that stuff anymore. I'm interested in understanding what is it that makes UI tests brittle, expensive to write, and time-consuming to run. So I've got an alternative pyramid, which I call the love-hate relationship pyramid. Recently, I've been moving, so I've learned about Marie Kondo, so you could call it Does It Spark Joy pyramid. So you should have many of the tests that spark joy, for whatever that means, and as few as possible of the tests that spark hate, right? Or sadness, or frustration. Now, what do we put up in these different buckets here? Well, one thing, what's important here? Well, speed, as I talked about initially, is important. If you have tests that take more than 10 seconds, you're going to lose your focus. You're going to go and do something else. So you don't want to rely on too many of those tests. You want to have relatively few tests that take more than 10 seconds. And you also don't want to have too many tests that take more than 1 second, because as soon as you have 10 of them, you've lost your flow, right? So most of your tests need to be really, really fast, and I'm talking about millisecond fast here. And I'm not making a distinction between unit tests and acceptance tests and integration tests and service tests and whatever people decide to call them. I'm just saying lots of really fast tests, very few really slow tests. Now, the other thing that makes us love or hate tests is determinism. Raise your hand if you've ever run a test that sometimes fails and sometimes passes. Right? Everybody hates that. That is just the worst, right? What's the point in that test? When it fails, you don't really know whether it's just because it's a race condition or whether you have a genuine bug in your system. So you want to have as few as possible of those tests that are non-deterministic. So I've just chosen to put them in arbitrary categories here. Tests that pass 80% of the time, you should have, or less frequently, you should have very few of those. And you should have, most of your tests should be completely deterministic, right? Another thing you can think about, love-hate, is maintenance cost. How long does it take to write a test? Well, if it takes a few minutes to write a test, that's great. But if it takes days to write it, or I'm not talking about just writing, by the way, it's maintaining existing tests, diagnosing tests that fail. When a test fails, you want to be able to figure out fairly quickly why it failed, that's usually what takes the most time. Fixing it, once you've found out why it fails, is usually relatively quick compared to diagnosing it in the first place. So you want to be able to get good error messages that will point exactly at where the problem is. So I think it's more productive to think about the love-hate relationship pyramid. You want to have lots of the tests that you love and very few of the tests that you hate. All right. So what is it that we're looking at when we are testing? Why do we test in the first place? Why do we test our code? Well, because we want to have confidence. We want to have confidence that our code works. But if you think about it, there are many different categories of confidence. There are many different characteristics of a system that we can have confidence about. And I think a lot of developers and testers, they tend to conflate a lot of these different aspects and try and get lots of different kinds of confidence from the same tests. So I don't have an exhaustive list of what different kinds of confidence that you should be looking for, but I'll give you a few just to give you an idea. So business logic, right? That's maybe the most obvious one. You want to make sure that the algorithms in your program are correct. For example, that if you say, for example, that you calculate the insurance premium correctly, right? Or that you move the money to the right bank account, or stuff like that. Is your business logic working correctly? That's definitely one thing that we want to have confidence about. But we also want to have confidence about the user interface if this is a system that has a user interface. You want to make sure that the buttons and the text fields and all of that stuff is wired up correctly to the underlying business logic. But this is a different kind of confidence than verifying that the business logic itself is correct. And because it's a different kind of confidence, it means that you shouldn't necessarily try and shoehorn all of these different kinds of confidences into the same test. I've got more for you. Platform confidence. Does my system work on Windows and Linux and Mac OS? Does it work in Firefox, Safari, IE, and so on? Does it work with Java version 8, 9, 10, 11, blah, 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 right? So you can have confidence about how portable your program is on different platforms. Again, it's a different kind of confidence. You should probably use a separate kind of test to get that kind of confidence. Integration. By integration, people hear different things when we talk about integration tests. To me, integration tests, that is the test that verifies that two systems, when you connect them together, everything works. So you can have an integration test between the part of your system that deals with payment and Stripe, for example. But you can test just that integration without testing everything else. But again, that's a different kind of confidence. Performance, you want to be confident that your system works well under load, that it's got the right throughput and latency and so on. And security, all these different kinds of confidences. And I think what I tend to see, when I go and look at other people's code base, and very often my own, I look at a test, and if you ask the question, what kind of confidence are we supposed to get from this test? I think that's a useful question to ask. And if you're not sure, well, maybe you should rewrite the test. Or if the answer is, well, we are trying to get confidence about all of these 8 things that I mentioned on my previous slides, that test probably isn't very good at doing any of these things, right? So when you write them and when you design tests, try and figure out what particular aspect of our system is that we're trying to gain confidence about. And I think it makes sense to split them up in different kinds of tests and have multiple different test suites that will give you just confidence about security, for example, or about business logic. But if you try and put everything into the same into the same magic cauldron, your tests are always going to be slow and brittle and expensive to maintain. So to illustrate how we can improve this stuff, I'm going to give you an example here with a little to-do app that I've written. Everybody writes to-do apps when they want to show off something. So this is a small React application written with a Node.js backend and a database to store all the to-dos. So let's have a look at what the architecture for that kind of application might look like. And I'm going to actually show you the architecture, not just with the runtime configuration, but also what it looks like with the test environment. So I'm going to start from the top. At the very top, we have a test that is going to test our application, our to-do application. And you'll see some Lego kind of shapes here. I'll get back to what those mean, so just ignore that for now. The test is going to talk to something here that I've called a WebDriver actor. I'll get back to what I mean by actor. Then there's going to be a browser, Firefox, Chrome, maybe a mobile browser. Inside the browser, there's a DOM. And we've written our application to interface with the DOM, the React application, or it can be jQuery, or it can be Vue, it can be anything, but some sort of JavaScript application. And then we need to communicate with the server over some AJAX calls, HTTP, WebSocket, whatever. So there's something that is responsible for talking to the server. And then we've got some HTTP here in the middle. And this is the client and the tests for the client. Then now the server comes into the picture. We've got a web server here, the part of it that receives the HTTP requests and maybe forwards that to another component, which is where the domain logic is. And then finally, we need to store everything in the database. Oops, no, we got a little data access layer here to decouple ourselves from the database. And then we have the database, right? Woof, all of these layers. And people are wondering, why is my test so slow? Any ideas? If I ran this test, how long do you think that would take? Depends. Let's say about a second, okay? So you can't have that many of these kind of tests before you start reading Hacker News or going on Facebook or Twitter or something. So if all your tests look like this, you're never going to get into the flow unless you have 2 tests. And if you have 2 tests, you're never going to get confidence, so we've got a problem. But why is this slow? What is it that makes computer programs slow? There's basically 2 things. We say that a program is bound by something. So you can say that a program running on a computer can be CPU bound. That means that if you buy a faster CPU, a CPU that's twice as fast, your program will run twice as fast, right? If the program is CPU bound. Now, this program here is not CPU bound, it's bound by another constraint. There's another constraint that limits how fast it can run. You can throw as much CPU as you want at this, it's not really going to make it any faster. It's I/O bound. Networking, input-output, sockets, HTTP calls to the database, that kind of stuff. That's what makes your test slow. So what can we do to make this test suite here faster? Well, I've said this one is going to take 10 seconds, depending on, well, for a to-do application, very simple scenario, but for a more complicated, I don't know, some sort of e-commerce site where you have to go through several steps, a test like this can easily take 10 seconds. How can we make it faster? Well, we can remove some of the slow bits. for example, up in the top here where we're doing WebDriver. WebDriver, by the way, is an amazing tool. Oh yeah, what kind of confidence do you get from tests using Selenium WebDriver? The things that I mentioned previously. Business logic, user interface, platform, performance, security. What do you get? Comedy. Comedy. WebDriver is an amazing tool for getting confidence about platform, right? You can use it to check that your application is working on all sorts of different browsers. That's amazing. And then you get confidence that the business logic is working as well, but you pay a pretty high price for that confidence. So what if we could have one set of tests that we put up in the red, you know, I hate them because they're so slow category, and we have very few of those just to verify that, yeah, this works on all the browsers. And then all of the other tests that are going to give us confidence about the business logic, well, they don't have to use WebDriver, do they? No, they don't. So let's just remove WebDriver. Like this. So I had a little animation here, but I'll run it again. If you look carefully, you'll see that those different Lego intersections here, which are contracts, allows me to do that. So I'm going to push out something here and put a new one in. So the same test now connects to the DOM, and I replaced that WebDriver Selenium stuff with something else, which I've called a DOM actor. Which to the test looks exactly the same. It's got the same interface. You know, the test just needs to talk to some interface that has one stud like that. It doesn't really care what it is. So this is a different implementation of that thing that just talks directly to the DOM without going through WebDriver. And in Node.js, I can do this because I can run the DOM inside of my Node process very easily. So now this test is a lot faster. It's just 1 second now because I removed the slowest bit of the system, the thing that was the most I/O bound, which is Selenium. And now I can look at the next bottleneck. Well, where is that going to be? Probably HTTP, right? Because I'm still making HTTP calls from my application. So let's see if we can remove that as well. Boom. Let me run that again. So, Goiko, is there a laser on this thing? No. But I'm going to remove the stuff in the middle, the thing above and below the HTTP thing there. I'm going to connect the user interface directly to the server-side domain logic. Boom. Now things are starting to get really, really fast. And again, I can do that because the way I've designed my application, the React app, it needs to talk to an interface which I've visualized here as something with 2 studs. Maybe there's 2 methods here, like add to do and remove to do, right? It doesn't matter whether that's an implementation that does it over the HTTP or I can connect it straight to the domain logic which runs on the server. This is easy to do in JavaScript land because you've got the same language on both the server and the client. But you can also do it with a more polyglot platform where you have, say, .NET on the server and JavaScript on the client. But it's a little bit more complicated. But you can still do it. Now things are getting really fast. Where is the last I/O bottleneck now? It's the database, so let's get rid of it. I'm going to replace the database with a memory data access object, which doesn't put stuff in the database, it just stores it in hash tables. Now I can run this test in 10 milliseconds. Now I'm CPU bound, because there's no I/O. All of this stuff runs in the same process. My test, my user interface, and my server-side logic, it's all in the same Node.js process. And I realize that not everybody here does Node.js and React, but the principle applies no matter what sort of platform you're working on. Try and put as much as possible inside of the same process so that you don't have to do I/O. When you do this, you're sacrificing some confidence. You're sacrificing confidence that you've integrated everything correctly, but you can get that confidence from other tests. We're focusing on getting the really important confidence here, which is the business logic. Now we're CPU bound, probably by the DOM, because the DOM is a bit, quite a complicated beast, needs to render stuff, so we can remove the DOM as well. Now, we have tests that run in milliseconds. But what we've kept here is the domain logic. The domain logic is still there. We're testing the domain logic without going through all of these layers of, quite frankly, uninteresting gibberish. It doesn't really spark joy. So let's put them next to each other. There's another variant. So by having these very clear interfaces between the different components in your system, you can mix and match and assemble them in different ways when you run your tests, depending on what sort of confidence you're looking for. Are you looking for performance confidence? Well, then we need the whole stack. Are you looking for business logic confidence? Well, then we only need a little bit of it. Are you looking for platform confidence? Well, then we need the whole stack again, and so on. So putting them all side by side, you can see that on the left here, you've got the really, really slow and expensive tests that give you that are few, hopefully, and they're slow, but they give you this kind of integration and platform confidence. And on the right, we've stripped out most of the infrastructure, and they're really, really fast. So let me give you a demo. And now I have to remember to turn off the mirroring here. There we go. All right. So I'm the cucumber man, but it doesn't mean that you have to use cucumber to use this technique. But since I'm the cucumber man, I'm going to illustrate how this works with cucumber. But you can do this with NUnit or whatever your favorite testing tool is. So I've got one scenario here for creating to-dos. Maybe I should show you the to-do list as well. It looks like this. So it's a server running. Yeah. All right, so I want to test this application. So here is a scenario. It says, given there is already one to-do, when I add get milk, then the second to-do should be get milk, right? Pretty simple acceptance test. So let's run it. Maybe enlarge that a bit. So what I'm going to do now, I'm going to run my test in all of these different assemblies or configurations that I showed you in the previous slides. We're going to see how long it takes. So what I'm doing here is I'm running exactly the same test in different configurations. And what's interesting here is to look at how long they take. So the one where I only have the DOM and the memory, actually, you know what? I'm going to run a bit more of them. I'm just going to copy the same tests and run it many times, so it becomes a little bit more, go away, one password. So it becomes a little bit more realistic. Just uncomment this. So we have 20 tests. They're all the same. There we go. Oh my God. There we go. All right, let's do this again. Boom. That was pretty fast. Boom, 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 boom. You can see it's gradually slower as I'm assembling more and more and more of the stack. I'm running the fast ones first. And now I'm running through the entire stack with the browser, which, as you can see, is just painfully slow. So it's important to have those tests just to make sure that it works on Firefox and IE and Safari and so on. But that's not where I need most of it. I'm just going to stop it because it takes too long. So if we look at this we have one configuration here, which is the one where we don't have the UI, we don't have the database, we just have the domain logic. Incredibly fast, right? Because there is no I/O, and I ran 20 tests in 11 milliseconds. How long is that per test? Half a millisecond per test. For my domain logic. And I'm able to do this because I've designed the application with very clear contracts between the different parts of the system. It's decoupled, so I can plug components in and out just like Lego. When I'm running the really, really fast tests, the to-dos are being stored, just not in a database. They're being stored in some sort of fake to-do store. Half a millisecond per test. So I can run 2,000 tests in 1 second. I've got the next one where I plug in the DOM. Things are a bit slower here. They're almost an order of magnitude slower. So 76 milliseconds for 20 tests. So a couple of milliseconds, still not bad. Here I'm running without a DOM, but just with HTTP. You can see that's even slower, but it's still pretty fast. And here I'm taking the DOM and HTTP together. But if you compare this with the first one, right, it is actually 40 times slower, even though it's reasonably fast here, but it's because it's a simple application. But 40 times slower is a lot, even though in my little toy app it's fast. And then finally we got the WebDriver, which I didn't even finish, but that was going to take something like 20 seconds. Right. So I've got, how much time do I have? 5 minutes? 8 minutes, wow. So I want to talk a little bit about how this looks from the perspective of the test. Most tests that I see are sort of hardwired to a particular part of the code, which is fine, but it makes it really hard to swap in and out different assemblies of the application. So what I've done here is I've introduced a layer of abstraction between the test and the system under test. And I've called that layer of abstraction an actor, which is a poor name because people think about the actor model, has nothing to do with the actor model. It's actor in the sense of something representing a person, right? So representing somebody, an actual human being interacting with the system. So the test only knows about actors, and the actor acts as a facade for interacting with the system, either through WebDriver or through HTTP, or maybe directly with method calls to the domain logic, but the test doesn't know. So you get two really important benefits from organizing your tests this way. One is what I just said. You can swap in and out different implementations and trade confidence for speed, or different kinds of confidence for speed. And that's really cool. I can run the same test to get confidence about platform, but I can also run the same test to get confidence about domain logic. But they're different. They can be run at different times. The other thing, which is more of banging the drum of BDD, is that when you write your test this way, you cannot refer to things like buttons and text fields and so on. You have to write the test in a technology agnostic manner. Because if my test said something about pressing buttons, how can I possibly press a button in the DAO? How can I possibly press a button in my domain logic? It doesn't make sense. So, and this is important because this allows, this is really the whole promise of behavior-driven development, that tests can be read by non-technical stakeholders. So this is kind of sort of like a bonus you get if you decouple your tests from the system under test. You're forced to make them agnostic of the technology so that they can be read by anyone. So the test here It can send some commands. It can say, I want to guess. Oh, actually, this is for a different example, for a game. But if you imagine this was for the to-do list, it could be add the to-do, and the other one could be get the list of to-dos. I've done the demo. Here is a list of some URLs you can go to learn more about this. I actually forgot to add, there's another one which is better. I apologize, I'm going to change that URL now. There we go.
Sub-second, not sub-secure.
Sub-second. Thank you, Goiko. Oh. Never do live coding in a presentation or live slide editing. There we go. All right, and I think I have maybe a few questions.